Also, just because we're recording, we do prefer if you unmute, but it's fine if you use chat. So, and also just to confirm, I can change it to grid. So we can see that this inner length right here is indeed 3 grids, sort of squares long, right? Make sense? Now let's move on to, wait one sec. Let's move on to this next one. So instead of telling you telling you guys the lengths of these rectangles here, like the side lengths of these rectangles, we give you the total length of this entire rectangle. So for instance, so this length right here is 11. This length right here is 7. So does everyone understand that? And how can we figure out the side length of this inner square? Can anyone like sort of think of a process we can use to do it? Just you can like say whatever. It's like this is a very open-ended sort of question. Like there's different ways to solve this. So one of the so why don't we first try to find, like, remember on this question here, we know these lengths, right? And we can use those lengths to find this one. So why don't we try to find out what these lengths are? Because we know that total length of this one is 11 and the total length of this one is 7. So can anyone see how we can figure out this length right here? So Justin says 6 minus 4 equals 2. Could you elaborate a bit more on like where you got 6, where you got 2 for these, and where you got 4? So he's saying bottom. So he says bottom. Like can you just unmute so that you can explain? I don't really understand. Okay. So basically what he's saying is 5 plus 6 equals 11, right? So we know that this total length is 11. And we know that this length right here must be equal to 6, right? Because this total length is 11 and this square already took up 5. That means that this one must be equal to 6. So does this make sense to like everybody here? It's a bit abstract. So like yeah, so can anyone, like, if someone doesn't understand, like please ask questions. Like you can ask any questions about what you don't understand about.
I just don't know what you're talking about right now.
So okay, so let's think about it like this. So what do you currently, like, do you understand, what do you currently understand about what's like sort of going on?
Like, I don't really understand anything that you're talking about. I just don't know what are we doing.
Yeah, so this is a geometry sort of problem. So these numbers here represent the side lengths, represent the length of this square. So you can think of it as like sort of pieces being put together, all of these pieces being put together, all of these squares, rectangles, all being put together like puzzles puzzle pieces, and then you have it like that. And you put them all together, and this square, this sort of piece, has side lengths of 4. This sort of piece has side lengths of 5. And as we saw above, we knew that these rectangles had side lengths of 7 and 3. So basically, we're putting together a bunch of different shapes to form one big shape. And
what does the question mark mean?
So the idea with this question is so that we can find out what the side length. So we can find out what this length right here is. How much is this? What is the length of this? Since we know all of these other lengths, we're trying to figure out what this length is. Right.
Oh, now I understand.
Yeah, yeah, maybe I should have explained it a bit more like thoroughly in the beginning, but it's okay.
Okay.
Okay, so now that we have this length of 6, can anyone see how we can just figure out the center one, similar to how we did it before? Okay, so if you remember before, what we did was we just subtracted 4 minus 1 because we saw that this length here plus this length here had to equal 4, right? Makes sense. And also on the left side, 4 plus 3 equals 7. 4 plus this 3 equals 7. And yeah, there's a lot of different ways you can solve for each of these using basically the same method. But we pretty much only need to find one, as like if we remember, the definition of a square is that each length is the same, but we only need to find one. And yeah, as Justin said, it was pretty, you can find it with many different ways. But for this one, since we only found this one, we can still figure it out. And so does anyone see how we can use this number that we just found using this total rectangle dimensions to figure out this length? Sorry if you're a bit dizzy from the... So it says the left side, oh wait. Okay, so okay, so Neo is saying 5 plus 4 plus n equals 11. So he's saying this plus this equals 11, and n is the side length of the inner square. Now, yeah, this is a very good method. So he's saying if this length is n, then we can do, and this total length is 11, then we can say that, yeah, 5 plus 4 plus n equals 11. Yeah, this is a very good method, but this is one of the ways we can solve it, but we'll get into this method later. But for now, let's talk about just how we can solve it arithmetically without using as much algebra, because oftentimes it's better to first look at it using like numbers, using arithmetic, and then using variables. So Joy is saying 5 plus 2 equals 7. Could you elaborate on like how you got these numbers? Just let's see where these numbers come from. So saying 5 on the right side is also just by the way, like a lot of you are sending me direct messages, but I think everyone would like to see like what you're saying. So it would be better if you send it into like the entire chat, like everyone in the meeting, instead of just like sending me direct messages, because I think everyone will want to see your thoughts. So the side of 7, so are you saying this side? Like this one? And so the side of 7, so 5 plus 2 equals 7. Yeah, so that's a very good way to find this length here. So yeah, so we did find this length, but actually you don't necessarily need to find this length to find this, the center one right here. We can just use the length that we just found, which is 6 and 4. But we could also, of course, use this length and 4 to find these lengths. So can anyone see how we can use either 2 and 4 or 6 and 4 to figure out this inner sort of square, the side lengths? So Joy is saying 4 minus 2 equals 2. So basically this length, similar to what we did before, minus this length has to equal this length, because this length, as it's a rectangle, yeah, this length right here is the same as this length because it's a rectangle. And thus for this total length 4 minus this length 2 must yield this one, which 4 minus 2 is in fact 2. And why don't we check that with the grid? Yep, we can see that it is indeed a 2 by 2 square. Yeah, so this is all this is pretty simple, self-explanatory stuff. But let's move on into a much more interesting puzzle. So in this case, the only information that we're giving you, it's still 3 squares like this, 2 rectangles, 1 big rectangle, obviously. But the only information we're giving you is that this square is a 6 by 6 square. And this total rectangle is a 15 by 17 rectangle. So can anyone see like how we can sort of like look through and find these lengths right here? Like this, these lengths. Neo, do you have an idea? So 6 plus 9 equals 15. So basically, Joy is saying that this total length here, this total length here is 15, this is 6. So you can pretty much do the same thing to find that this one is 9. Now, similarly, we can also do this to find out that this length is 1, because the total length here is 7. But let's think about it. How do we proceed from here? So if anyone has any ideas, you can just shout it out, because it's a hard problem. So a lot of the times when we are doing these kind of relatively hard math problems, a very good thing to do is to like put variables to, as Neo did before, which is pretty smart, honestly, to sort of look at what we know and what we don't know. So right now we know that we have 6, this length is 6, this length is 6, this length is 1, and this length is 9. So this is the stuff that we know. But what are the things that we don't know? So obviously we don't know this length, right here, these 4 lengths, which are the same. So why don't we call this length, I don't know, let's call it x. But what other sort of lengths do we not know? So x is each of these is all equal to x, and x is just a number. We don't know what it is, but it's just a number. So what other lengths here do we not know right now? What is unknown, an unknown number? So does everyone understand like the sort of idea of looking at all of the unknowns and the knowns here? Like, if you have any questions about this idea, you can shout it out. Okay, so everyone, I think it seems like people do understand the idea, but so why don't we look at what other unknowns there are? So we have what other kind of unknown values we have here. What lengths do we not know? Because for instance, in this case, we know what this length is, right? Because this length is obviously 6 because it is a square, of course. 1 is that small, and so the height of the 9 is like the little height of the 9 is 2. Sorry, what? Oh, so what Joy is saying is that I think this is what he's saying. This kind of looks like it's double this. I will not reveal if it is or not, but it might be. But you can't just use looks, obviously. But so as I was saying, this length we know and this length we know, right? Because these are all 6. This length we know it's 1 because this is a big big skinny rectangle, I guess. And this length here we know also because it has to be 9 because this is a big rectangle. So 6 minus 2 equals 4. So so where did the 6, the 4, and the 2 come from in this case? Joy. So the 6 by 6 square, and then the 4. Mm-hmm. Okay, so I think she forgot that this length, we actually don't know this length because all we know is all we know is this length, this length, this length, and this length. So and all of their sort of reflections. But what other lengths do we not know? Just it's like what other lengths here do we not in fact know? Okay, so as I mentioned before, we do not know what this length here is, right? This length, we actually don't know what it is because this length, if we knew what it is, then we would easily be able to find x. But since we don't know what this is, let's just call it a new variable. So generally, I'll just call it y. It's kind of boring, but I'll just call it y. So now we have these variables, and we also have these lengths here, which we don't know as well. So this square, I did not give you this information before, right? So we have, let's just call it z. And then this right here, z. Now, what is really nice about variables is that we can just create relationships, like not, okay. We can like create relationships between these variables. So can anyone see any relationships between these variables? For instance, what does x plus y equal in this case? This length plus this length. Can anyone see what this length plus this length equals? So Neo is saying that this length, oh, Justin, sorry if this was a bit confusing, but it was actually 15 was this length and 6 and 7 was that one. Yeah, it's okay. But Neo was saying x plus y equals 6, right? Because this length, this big length here is 6. And we have these little x and this little y. So we can just write this down saying x plus y equals 6. So does everyone see like how this makes sense? You know, is this clear to everybody? If it's unclear, you should you know, say it. It's okay. Okay, nice. So I'll just assume it's clear to everybody, but what other, okay, what other relationships can we find? So say, let's just say, I don't know, like just any other relationships. And we can even do subtraction as well. So we had x plus y, but why don't we also look at x plus z? Oh, Joy says, I literally know the answer, but I cannot explain it. Okay. Well, Joy, so if you think you know the answers, I think it's cool to like just put an estimate and like we can see if it is correct, and then you can sort of work backwards to like how you did it, or like the sort of process or the thought process. Like a general thought process is also great as well. So the square's height is 4. So is this like, so this square here? Oh wait, oh, this square. This square's height is 4. Okay, so if we look at that, you know, it is in fact 4, right? Because obviously, because I like to I drew this on the graph, but if we assume that the square's height is 4, then we know what x is, right? Then we know that x is in fact 4. X plus y equals 6, and y plus 6. So since we know that x is 4, how can we find, say, z? Because because like in algebra, if you know x and y, if like there's these relationships, then if you know x and y, then you can figure out what z is. If you know what z and y is, then you can figure out what x is. You can do all of these sort of calculations. So now that we know that 4 plus y equals 6, can anyone see that what y is? Because like we sort of I sort of just figure out the answer, just what x is. So if we have 4 like this, then can anyone see how we can figure out what y is? So yeah, so if this is kind of confusing, basically what we're doing is we're working backwards to find out what kind of process we can use to sort of figure this out. Okay, so Joy just skipped skipped my stuff and just straight on found what z is. So z is 4 plus 1 equals z. I mean, yeah, that means that z equals 5, which, yeah, that pretty much, that makes sense. So since we know that 4 plus 1 equals z, and then how can we figure out what y is? How can we figure out what y is here? And if you remember, 4 is x. Because we can do something very similar, right? So 4 plus 2. So that means that we get 4 plus y equals 6, which just means that y equals 2. And that's what she was saying. So we have these sort of relationships, but what is great is that since we figured out all of these relationships just based on x being 4, we can just replace all of these 4s with an x. And this is how we can sort of work backwards to look at the process that we sort of use to find all of these variables, because all of these variables are related to each other. So you can just do all of these backwards, all of these things forward and backwards, upside down. Do you want to say something? Or, oh, Gavin. Whoops.
No. It's just my internet not working really well.
Oh, okay. That's quite unfortunate. But yeah, I'll put up a bunch of resources and like put up all of these steps so that you can look at them later if you want. So, but now that we have all of these sort of relationships, now that we have all of these relationships, we can also figure out we can also figure out x plus z. What is x plus z? So basically what we're looking at is what is this length plus this length. And if you remember, this giant thing is a big rectangle. So this length has to equal this length. So yeah, so x plus everyone's getting excited about this 9, but x plus z must equal 9, right? Does that make sense to everyone? So now we have these 3 equations. So generally speaking, in algebra, if you have 3 variables, then you would need 3 equations or 3 relationships to figure them out, find what these variables are. Like generally speaking, it's not always true, but generally speaking. But now, how do you think we can figure out what x is using these 3? And in figuring out what x is, we can also figure out what y and z is, just using this without skipping straight there and using a good eye to find x. Okay, so has anyone here learned this kind of like equations, these kinds of sort of algebraic ideas? Okay, that's okay. Because what we are basically looking at is we're saying all of these values are interrelated. And because we know that x plus 1 equals z, then we also know that x plus z equals 9. We can substitute, we can put this z in there, because then we would get, because z equals x plus 1, right? Because z equals x plus 1, then in this case, x plus z also equals x plus 1. So does that make sense, everyone? It's an interesting concept, but does that ever make sense to everyone? Okay, so Neo has already, as a overachiever, he's already gone well and beyond. But I just want to make sure this makes sense to everybody, that x plus z equals x plus 1. Okay, so since this makes sense, now we can just use this to, since we also know that x plus z equals 9, right? We remember this, then we know that x plus 1 also equals 9. And we don't even need this anymore. We can just, now we know this sort of is true. And if we know that this is true, then we can use this to easily figure out what x is. So x plus 1 is basically the same thing as 2x plus 1, right? Because in addition, it doesn't matter how you group these things together, it's still the same thing. So even if you got rid of these, it would still be the same thing. And 2x plus 1 equals 9. And can anyone see how we can figure out x using this formula? So Neil's already figured it out, but does anyone else want to give it a try? All right, so basically, we just know that we can just take off 1 from each side. We can first isolate this, this sort of term, this right here. And then by taking off 1 from each side, it's like a balance scale. You just take off, you subtract 1 from the other side as well. So now we just have 2x equals 8. And since now we just want to get rid of this, 2. And in order to get rid of this 2, we just need to get rid of the 2 on both sides, which means dividing each side by 2, which gets us x equals 4. And if we remember before, x does in fact equal 4. Hip, hip, hooray. So using this x equals 4, we can easily figure out what all of these other things are, which we did before. So does this like sort of process of variables, all this stuff make sense to everybody? Does anyone have any questions about this process? US says that she has a question. What is your question?
What? I just don't understand about x plus y equal to 6.
Oh, x plus y equals 6. I actually realized that it wasn't entirely necessary. You don't necessarily need that. But x plus y equals 6, it's sort of you don't actually need that, but it's information that is useful in this case. So x plus y equals 6, right? That's do you understand why that's true, or are you asking about like why we need this or why we need this? Because the truth is we technically do not need this, but it is another way to figure out the question, because we can also do a similar thing with x plus y. Does that make sense to you?
Yeah.
That's a okay. That's a kind of a all right. So anyway, let's move on to basically the finale of this question, where the only information we give is this 13 by 9 rectangle, and you just need to find this. We don't give any information about the side lengths, any of these side lengths. We just give you the total length of the rectangle. So one of the reasons why I put x plus y equals 6 here is actually because this shows that we have extra information. And sometimes if we have extra information, we actually don't need some of this information, which means that in this case, we actually don't need this information of this. We don't need this information. It's not like obviously that clear cut, but it sort of suggests that we might not even need this information and we can just figure it out. So we can do something similar to what we just did with like all of the different side lengths and all of the different relationships between all of these side lengths to figure out the sort of unknowns that we have. So for these rectangle lengths, we can easily just figure them out using the lengths of the squares, right? So similar to what we did before, let's just label each of these squares with variables. So x, y, and z. Actually, let's do something similar like this. Z, 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 z. Okay, so can anyone sort of think of any relationships that these variables sort of have? Now, this is a very hard problem. This is actually the hardest problem on AMC 8, but I think like slowly you can figure it out. It's quite smart the way they figure it out. So I think you should think about it for a bit, and then see if anyone has any ideas of relationships between these points, between these variables. And by the way, this total length is 13, and this total length is 9. So does anyone have any ideas about how we can figure this out? Neo, do you have any relationships that you thought of? Joy, Gavin, Yue, Justin. Okay, so this is quite hard, but we can see that x plus y plus z equals what? What do people think x plus y plus z equals? Does anyone have an idea as to what x plus y plus z? Or to better order it, what about y plus x plus z? Can anyone see what this is? Yes, does it have to go? But okay. We'll miss you. So Neo is saying y minus x plus z equals 9. Okay, that is a very good cool relationship. And does anyone like see why or want to explain why this is true? All right, so basically, what is this length? What is this length right here? What is this length? So do people like see what this length is? Or easier, we can see what this length is. Now we know that this total length is y. And since we have this smaller length with this x, we know that this length right here is y minus x. Because this is a rectangle, we know that this length all the way over here is also equal to y minus x. So does it make sense? And since we know that this total length right here is 9, we know that y minus x plus z equals 9, which is what Neo said. Which is yep, is what Neo said. And move that bit. But let's also have a look at what is y plus z plus, what is y plus z plus what is y plus x plus z? Now, similarly, we can look at what this length is. So does anyone see what that length over there is? So does anyone see what this length is in terms of x and z? Okay, so since we know that this length here plus this length here must equal this total length of this sort of rectangle, of this rectangle side, we know that this length is x plus z, and therefore, because it's a rectangle, we know that this length is also x plus z. And because we know that this total length is equal to this little length plus this little length right here, we know that y plus x plus z equals the total length, which is, as we defined, 13. And now people might be wondering, like, how do we proceed from here? So as I mentioned, when I mentioned before that generally speaking, you need 3 variables to solve for, you need 3 equations to solve for 3 variables. That's actually not true in this case, because we can just group x, we can just group y and z together. So instead of calling this, so why don't we just group them all together? So if we have y plus z, we'll move this over here. If we move y plus z together like this, plus y equals 13, we can see that this is the same thing as that, right? Does that make sense? Okay. So because we have this sort of thing, we can also do the same thing over here. Because of the associative property, we can see that z plus y minus x also equals 9, right? This makes sense. And since we can just group these together, we get that z, whoops, I realized I messed this one up. We realize that z plus y minus x equals 9, and y plus z plus x equals 13. And obviously y plus z equals z plus y. So we can just change this to y plus z. Now that we group these two together, we can do something very similar to what we did before. And now since we can just add x on both sides to get rid of this x, we can just do y plus z equals 9 plus x. Does that make sense, everyone? Because if we add x to both sides, then this x is canceled and this x stays. So does that make sense? Okay, I think that's this is like a pretty simple algebra, but now that we have this information, we can just plug this sort of thing into here, which is 9 plus x equals 13. And we can do this because we saw that this equals this. And thus we can just put this in here, add x, and that gets 13, which means that 9 plus 2x equals 13, and therefore 2x equals 13 minus 9, which is 4, and x equals 4, which is x equals 2, which is what Neo figured out. And yeah, it looks about like 2. It looks kind of 2-ish. And what this is very interesting because it sort of seems like if you only have this information, you cannot figure out what the center thing is, but you actually can. It's like using these relationships, you can. And why don't we look at a more generalized example? What if we have an A times B rectangle? So using a similar like strategy, a similar like idea as what we did before, just finding out all of these things. Can anyone see how we can find this length in the center in terms of A and B? Because obviously if we don't have numbers, we can't figure it out exactly, but you can figure out a sort of relationship between A, B, and the center square. So can anyone see how we can do this? Okay, so we can do something very similar by adding these variables like this. And we can just solve for these again, right? So what is x plus y plus z? Does anyone remember what that is? And, oh yeah, and by the way, this length is A and this length is B. So can anyone see how we can figure out what y plus x plus z is? If this big length right here is A. Okay, so based on what we did before, we know that x plus y plus x plus z equals this big rectangle length, which is A. In that case, it was actually 13, but in this case, because it's all variables, we know that A is 13 in that case, but now it's just A. And similarly, we can do the y minus x plus z, which is equal to this length, which before was 9, but is now just a variable, which is B. And since we can do a very similar thing, group them by x plus z plus y equals A, x plus z minus, y plus z plus x equals A minus x equals B. Then we can do something very similar by just saying y plus z equals B plus x, which means that we get, I'll have to do this, which means that we get a, since we can just substitute this in, we get a b plus x equals A, which means that we get 2x, b plus 2x equals A, and 2x equals, right? We can just take b from both sides, A minus B, and we get x equals A minus B over 2. Okay, so kind of rushed through this, but this is how we can figure out the relationship between x and A and B. So another way to think about how, like, make this a bit more intuitive, sort of this, how we can figure out x just using these lengths, because it doesn't seem like you can, is by looking at this. So in this case, we have, instead of these two sides being perfectly aligned, this sort of cut out rectangle is there. And in this case, can we find side length of the x in the middle of these side lengths? Can we figure it out? Okay, so basically we cannot figure it out because we cannot find this information right here, y minus x plus z, because, oh wait, yeah, we cannot figure out that information because this length is not, wait, go back. Because we know that, because this length, wait, oh, wait. Because x minus y is not equal to this length. This length is not equal to this length, or wait, no. Yeah. And therefore, we cannot figure out this sort of equation. We cannot find this kind of equation, and thus we cannot figure it out. So when they tell us that these are aligned, this is actually very important information to know, because if they aren't aligned, then you cannot figure it out. So this is this sort of problem demonstrates a lot of the principles that you need to use in some of these competitions. And so, like, a lot of people were wondering, like, what do we, why are we doing all of these things? It's, a lot of it is because we're trying to build a lot of these principles, these ideas inside to, like, help you understand how we can approach these problems. Because the way you approach a problem is much more important than the amount of math that you've learned previously. Because in reality, this problem, which is still quite hard, is using quite simple, like, algebra. It's not very complicated. You don't need to know that much stuff. And thus, it actually, a lot of competitions, it's about the way you approach a problem, not about the amount of math knowledge that you have. All right, so it's 8 o'clock. So thank you everyone who came. Thank you everyone who came, and yeah, so y'all can leave if you want. If you want to stay around to ask any questions, you're welcome to.